Students,
Good
morning,
morning, sir.
students.
Good morning, sir.
Could you see the worksheet that I sent you yesterday? No. Okay, fine. So see then what is remaining in friction we'll finish today, and in the next class we go on to the next chapter, work. Okay. So today's class we are having some special type of questions. Okay, in friction. We call them block on block problems. Okay. Block on block. Block on block problems. And you need to understand it before solving them. Okay. So what to understand in that, or what the concept is actually, that you will see. Now suppose here is one block and there is another block. Let's say this is A and this is B. There is friction here. There may be friction given at the base also, there may not be given. The concept is same that I am telling you right now. Then we have to apply the force. We can apply the force on the top also, we can apply force on the bottom one also. Okay, what will be asked? It will be asked from us that find the acceleration of both the blocks. Find the acceleration of both the blocks, that will be asked. Find acceleration of both the blocks. What is the concept in this? The concept is we have to check first, before going for the individual blocks acceleration, we have to check first whether they can move together or not. If they cannot move together, then only we'll be going to calculate its separate acceleration. Okay, so first checking is, what is the way of solving it? Method of solving. The first step is find, can both blocks move together? Can both blocks move together or not? And this is the first condition. If they can move together, then there is no problem, we'll find it. If they cannot move together, then we will go for the separate acceleration. Okay. How to see that whether they are moving together or not? So, finding common acceleration first. First, you'll find common acceleration. Now, if suppose that its mass is small m and its mass is capital M, and you are providing force from here to the lower block. Okay, and we are saying that both are moving together. If both are moving together, that means I can write them as m plus m. They'll be written as m plus m. And this is smooth surface here, according to the question given. Okay, and you are applying force F. So common acceleration, if I assume it is A, then we can write F equal to m plus m into A. That means acceleration is F by m plus m. Perfect. This is the acceleration. But whether both are moving with this or not, I don't know yet. Okay, I just written if they are moving together, then this should be the acceleration. Okay, now the question is, this is moving with the acceleration, understandable. Why this upper block on which there is no force acting, why this has to move? That's our question. So here our answer is, this is moving because of the friction between the two. Okay, A is moving because of the friction between the two blocks. So okay. So first thing is, see here, first this method also we have to write, then we will start solving it. Finding common acceleration first. Right, we found it. Then the second step after that, rather third step. See that the acceleration to the block on which force is not applied, to block on which force is not applied, can be given by friction or not. Can be given by friction or not. That's third step. If friction can give this acceleration, then both are going together. If friction is not able to give this, then both will be moving separately. Okay. So the fourth step I'm writing here now. If friction can provide this acceleration, then both will move together. Okay. So first is this. If you can understand these four steps, then we can solve any question block on block. Otherwise, it is difficult to solve these kind of questions. Okay. So first you note this, then we will solve it, and then we solve a few more questions so that it is very clear to you how to solve these. Okay. So first note these four steps. Done?
1 minute.
Okay.
Done.
Okay. So I'm erasing this, our steps method of solving. Then we'll solve it. Right. Okay. So the first step, sorry. So we'll solve it. So the first step says that first find their common acceleration. And okay, if there is a common acceleration between the two, we can consider them as the total mass is m plus m, force applied is F, This is the smooth surface. So we can write very easily that F is equal to m plus m into a. And acceleration will become F by m plus. No problem in that. Now we have to go towards the block which is not having any force, or force is not being applied on that. Which block is that? That upper one. So this also has to go along with this one with acceleration A. So as I said that this is possible only because of friction. Because when you pull this one in this direction, on block B, friction acts backwards. But its reaction on block A, where? Forward. So it's friction only which can take it in that direction. So what we have to see now? We have to see how much is the friction force. Which friction? Limiting friction. Because they want to be together. That means this want to be at rest with respect to B. This want to be at rest with respect to B. So what is the limiting friction between A and B? Limiting friction between A and B. Now, limiting friction between A and B is mu n. We know that. That will be mu n. And in this case particularly, if we are going to make a free body diagram of this mass m, we know that n value is actually mg. N value is mg, right? So we can write mu mg. Now what? Now this mu mg, this force of friction, need to be greater or equal to the force required by this block to move with acceleration A. What is the force required to move? That is ma. If force of friction is greater or equal to mass of this block and its acceleration, then both will move together. Then both will move together. With acceleration F by m plus. This is what you have written in condition. And if suppose force of friction is less than this one, both will move separately. Okay, note this, and after that we are going to solve the problems. If force of friction, which force of friction? Limiting force of friction is greater than mass into acceleration, then both will move together.
Done, see.
Okay, so see then, let's make the question now. So question number 1 goes like this. Let's say this is 8 kg. And here is another block. Its mass is 4 kg. coefficient of friction here is 0.5. Let this be smooth to start with. And we are applying the force from here. That force is 24 Newton. Okay, we have to find, what is the question? Find acceleration of both the blocks. Okay, that's the question. Simple. Note this question. We'll solve it. We'll solve it together. Done?
Yes, sir.
Okay. So what is the first thing we'll do? First, find out what is the common acceleration. If they move together, what is their common acceleration? Okay. So common acceleration. If they have to move together, then what is it? We know that it has to be F by m plus m. Common acceleration will be F by m plus m. What is F? 24. And m plus m is 8 plus 4. That's 12. That means acceleration is 2 meters per second square. Good. Next thing, we'll be finding force of friction between these two. So 4 kg is free body diagram. We know that here is 4G acting. There is N acting, normal contact force, and N value is 4G. Now, what is the limiting friction here? The limiting friction, it's mu N. What is mu? Mu is 0.5 given here. And N value we got 4G. G is 10. 40 into 0.5, that is 20 Newton. So far, good. Now, we have to check if we want to move this block with the given acceleration of 2, because acceleration, common acceleration we got is 2. If this block has to go with the 2 acceleration, how much force it requires? How much will be the force which can take it with the acceleration of 2? It's an 8 Newton. How you got? M into A. Okay. Force required to move 4 kg with 2 meters per second is 4 into 2. That is 8. Now what we learned? We learned that if force of friction is more than this, then both will go together. Now check. Yes, this is 20 Newton and this is 8. So both are going to move together only. Force of friction is greater than ma. Then both blocks will move together with acceleration 2 meters per second square. Okay, sometimes they ask you what is the value of force of friction between these two. So we write 20 Newton. That's wrong. That's limiting value. How much friction does it require to move with 2 meters per second square? 8 Newton. 8 Newton, because that is a requirement. Okay. Force of friction between the blocks in this question. is 8 Newton. Not 20 Newton. Limiting value, maximum value is 20. But do we require maximum? We don't require. It's only going with 2 meters per second square. If it move with 3, then 12. If it moves with 4, then requirement is 16. If it moves with 5 meters per second square, then we will require friction 20. You understand that?
Yes, sir.
Okay, come on, note this one. Done?
Yes, sir.
Okay, let's go for the next question. Next question is like this. Three kg, 2 kg, friction 0.4, and force is 15 Newton. Force 15 Newton. Take 10. Ten also is too much. Take 5 only. Right. So find acceleration of both blocks and friction between them. And friction between them. Okay, now what is the difference between the last question and this question? Last question, we applied force on the lower block. Now I am applying on the upper block. Question is same. Method is also same. Okay, and we have to find what are the accelerations and friction between them. So note the question. We'll see how to solve this one now. Done?
Yes, sir.
Okay. First, find out common acceleration and tell me what is common acceleration. That I am not doing. Give me common acceleration first.
One.
Yeah, this is smooth only. So common acceleration is 1. F by m plus m. 5 by 5. 1 meter per second square. Now, second question from you is, find out how much is the friction between 2 kg and 3 kg. Find it. Which friction? Limiting friction. Because limiting friction is the first thing that we calculate here. What is the limiting friction between 2 kg and 3 kg? Come on. Friction limiting. Come on, students. I am not doing. You only are doing. Friction limiting.
Eight.
Yes. 0.4 into 2g. That is 8 Newton. Fine. Now what we have to do? This much we did. Now the question is, on which block we have not applied the force? Upper block or lower block? See and tell me. On which block you have not applied the force? 2 kg or 3 kg? Lower block. We have not applied the force on 3 kg. And still we want 3 kg to move? Yes. Which direction? Forward. So who's doing it? Friction. Friction has to pull this block. With what acceleration? 1. Friction has to pull the block with what acceleration? 1 meter per second square. That means mass into acceleration is 3 into 1. Okay? Friction required to pull the lower block with acceleration of 1 meter per second square is equal to what? Mass into acceleration. That is 3 into 1. That is 3 Newton. Now we will check whether limiting friction is more than this or not. Check. Is it more?
Yes, sir.
Yes. So what do you write here? You'll be writing, since limiting friction is more than ma, that is limiting friction is more than 3 into 1, then both blocks will move together. Will move together with what acceleration? 1 meter per second square. With 1 meter per second square. Part number 1. Part 2, what is the friction between them? Friction between them is 3 Newton. Not 8. Friction between them is 3 Newton. Is this clear?
Yes, sir.
Okay, note it. Done? Completed?
Done, sir.
Okay. Now see, another question we will frame from the same setup. What question is this time? Similar kind of a setup first. Okay, it's 5 kg. And this is how much we can keep? 3 kg only. Okay. This is force F. And here, coefficient of friction, let's say 0.4. And this is smooth only. Question asks us, find the maximum value of force F so that both blocks can move together. So that both blocks can move together. Now that's the question this time. In earlier questions, I gave you force F and I told you to find out the common acceleration and acceleration of other blocks. This time around, he says, find the force itself so that the two can move together. Okay, so note the question, see how we are going to solve this. Done?
Yes, sir.
Okay. So then what to do? First is go for again common acceleration. How to write common acceleration in this case? Common acceleration in this case is going to be F by 8. Okay. Solution says find common acceleration. I don't know F value. So it will become F by m plus m, that is F by 8. Right. Now 3 kg also has to move with this acceleration because he says find the maximum force which can make them move with the common acceleration. So 3 kg also has to move with this acceleration. Okay. So for 3 kg, how much friction is required? Friction required is equal to mass of this into acceleration common. Mass into acceleration. That's what we learned. 3 into F by 8. Correct. How much is limiting friction between the two? That is most important thing. So friction limiting. How much is there? Say mu n. Mu is what? 0.4. And what is n? N is 3g. N is 3g. Because 3 kg block we are talking. So here is 3g. And there is n. So n is 3g. So we are putting 3g is equal to 12. Now, if this required force is less or equal to this, then both will move together. We know this. Okay, that is the condition. For moving together, this MA should be less or equal to force of friction limiting. This is what we learned. So MA means 3F by 8 should be less or equal to 12. Right. So what are we getting? This is 3 4 ja, and F should be less or equal to 32 Newton. So he's asking maximum value. We are saying F should be less or equal to 32. So what is maximum value? 32 Newton. So F maximum is 32. So till this F is 32 Newton, both the blocks are going to move together. Did you understand?
Yes, sir.
Same thing only, but they asked this force this time. So conditions are same. We are not changing the conditions. This is the same condition. Force of friction required should be less than limiting or equal to limiting. Here also we did the same. Okay, so note it. Done?
Yes, sir.
Okay, now in this question itself, the same value, everything setup is same. This force I am going to apply on the top block. The question is same from you. What should be the maximum force so that two blocks can move together? Okay. Find maximum value of force F so that both blocks can move together. So that both blocks move together. Okay, you are finding it. Come on, start doing it and tell me what the answer is. Anyone got the answer?
Sir, approximately 19, sir.
19.2.
Yes, sir.
Okay. So when you apply the force on the top, A common is same. There is no change in this one. Then instead of 3 kg, now we have 5 kg. Because 5 kg we want to move now. So 5 kg. So friction required is 5 into F by 18. So this 3 is not required, it will be 5. Limiting friction, same. Because this is between these two. So no change as far as limiting is concerned. So there, M into A, this will change, only this will be 5F by 18 and nothing else. Everything else is same. This is 5F by 18. And that side is 12 still. So F will be less or equal to 96 by 5. Less or equal to 96 by 5. That's it. That's our answer. (96 by 5). That means maximum value is 96 by 5. That is 19.2 Newton. Is it clear, students?
Yes, sir.
Okay. All the girls are clear with it? No problem?
No, sir.
Okay. Now let's make it a little more complicated. Let the values be same over here, okay? Okay. I'm just removing it from here. So what complication we can add in this? More complication I can add is, I can give you that this surface over here is not smooth. Here also friction is there. Okay. So let's say here friction is 0.1. Now question is same. Find the maximum value of force F so that the two can move together. So far we are doing for together only. After this is clear to you, I'll be going for the different accelerations. Okay. So now again, question for you is find maximum value of force. Shall I give maximum or first you will find acceleration? Okay, let's find acceleration first. I'll give you the force value. Force value I'll give first. Okay. Force value is 24 Newton. Okay. Find acceleration of two blocks and friction between the two blocks. Between the two blocks. Okay, let's try. Okay, done. So tell me, you will do or I should do? What we can do? First, take them together. Here also friction is at both the places, but take them together. Take them together means is 5 plus 3, 8. So 8 kg. Consider them together. How much force we are applying? 24 Newton. Now 8 kg when you're there, you know that here friction is there. There is friction. Now you want to make it move with certain acceleration. You know that you want to make it move. That means the force applied by you should be more than this. What is this? This is limiting friction because you want to make it move. So here you know that 8G is acting. And in this direction, there will be normal contact force. Okay. So fine. This equation will become 24 minus force of friction equal to 8 into their common acceleration, whatever that is. So 24 minus mu n equal to 8a. So 24 minus mu. What is mu we have taken? 0.1. So 0.1 into 8g. So 8g equal to 80. Now 8g means 80. 80 into 0.1 means 8. 24 minus 8 is 16. So 16 equal to 8a. Acceleration is 2 meters per second square. But still we have to check whether it's possible or not possible. Question is not over that we have found acceleration of the two blocks, but we don't know whether they are moving together or not, first of all. So what is this? What is the catch? What is the main concept? The concept is here. Sorry. Yeah, here only. Concept is the friction here should be able to give this 5 kg block this much acceleration. If it can, then only they will move together, otherwise they will not move together. Okay, so we have to see here now. So what is the friction here? Okay, limiting friction is what? So let's check. Limiting friction is again mu n, but between these two. And that we already found in the previous question. What is what? 0.4 into 3g. That means it's 12. It is 12 Newton. So friction acting on this one is 12. Right? And this friction should be able to give 5 kg block this much acceleration. Is it possible or not possible? We have to check. Right. So let's see 5 kg now. So on 5 kg, your limiting friction is acting like this. How much it is? 12. Here there is one friction acting, which is this one. How much is its value? We already calculated. How much it is? 8. And its acceleration we have written as 2. I don't know whether it's possible. Not possible. Check. Is it possible to make 5 kg block move with 2 meters per second square? This is 12. This is 8. So 12 minus 8 is 4. Maximum possible acceleration of 5 kg is 0.8. 4 by 5. And here we are saying 2 meters per second square. So is it possible? No. It's not possible. So here limiting friction between the two cannot make them move together. So how will they move? They will move separately. They will move separately. Are you able to understand, students? Say yes or no.
Yes, sir.
First thing is, this is exactly in the same way we calculated as we were doing. But only thing is, new thing, this friction came because here is friction. So we included that and we calculated acceleration. Fine. In the same way, common acceleration is this. Then we went for limiting friction between the two. It came out to be 12. Right? Now 12 Newton should be able to move this block 5 kg. So we made free body diagram for 5 kg. This is 12 Newton acting in this direction. How much is friction over here? Friction over here we already calculated how much it is. 8. We are placing it 8 over here. So now what is the resultant force? 12 minus 8, that is 4 Newton. Can 4 Newton acting on 5 kg move it with 2 meter per second square? No. So force of limiting force value is less than the required value. Okay, so both will move separately now. So limiting value is less than required. So what will happen? Both blocks will move separately. So now what? Now we have to calculate their accelerations. If they are going to move separately, then we have to calculate their acceleration separately. This will not work. So why we do this? Why we did this? Just to check whether they are going to move separately or together. This is just the check. Okay, so first note this, then we will calculate acceleration separately. Okay, note it. Completed?
Yes, sir.
Okay, now let's find out the acceleration of both the blocks separately. Let's see. So first we'll solve for 3 kg. So 3 kg is here. On 3 kg you are applying force 24 Newton. And between 5 kg and 3 kg, there is friction. So friction. Which friction? Limiting. Because you want to make this block move on 5 kg now. Because both are moving separately means 3 kg will move on 5 kg. What is acceleration? That's what we are finding. Let's say A1. So 24 minus limiting equal to 3A1. Limiting value we already know, 12 Newton. So put it. 24 minus 12 equal to 3A1. That is 12 equal to 3A1. That means A1 value we are getting as 4 meter per second square. It's over. Finished. 5 kg. 5 kg is what? Okay. Now on 5 kg, there is friction applied by 3 kg. Which direction? Forward. We already have that diagram. Same diagram only. So there is a friction acting forward. How much? 12 Newton, limiting one. Then there is a friction between ground and this block. And how much is that? 8 Newton. Not 5G here. Why not 5G? Because on this one, 3 kg is also applying the force from the top. If it's free body diagram, if I have to make, it will be like this. There is 5G. Okay, there is normal contact force by 3 kg. So N1. And then it will be N over here. So this N will be what? N1 plus 5G. And N1 is how much? 3G. So that's why it becomes 8G. And this force of friction becomes mu into 8G. That is 8 Newton. 0.1 into 8G. That's 8 Newton. Okay. So this is 8. So what is the acceleration? 12 is here, 8 is here, and mass is 5. So we'll write 12 minus 8 equal to 5A2. So this is 4 equal to 5A2. So A2 equal to 0.8 meter per second. So A1 is 4 and A2 is 0.8. Is this clear?
Yes, sir.
Note it. Completed?
Yes, sir.
Okay. So now one more question for you. This time this is 6 kg and this is 4 kg. This is 0.5, mu is 0.5 here, and here is 0.1. Okay. And from here I am applying force 8 Newton. Okay, what you have to give me? Acceleration of both the blocks. Okay, find acceleration of both blocks. Come on, that's question for you. What is common acceleration? I think common acceleration will not come because force of friction is more than 8 Newton. Am I correct?
Yes, sir.
Sir, the answer of upper block is 3 meter per second square and the lower block is 1/3 meter per second square.
But how you got it? Because it's not able to move. First, if you take them combined mass, 4 plus 6 is 10. Then friction is 10. And you are applying 8 Newton. So that means they are not moving. Then we'll go for the upper block. In upper block, if we say 8 Newton you are applying over here and the friction here is 20. So acceleration in fact is 0 here. Nobody is moving. Okay. How you got, Akhilesh?
Sir, directly proceeded with the fourth field.
So we cannot move. With this 8 Newton at least, nobody can move. So I have to increase the value of this. Okay. Good that you people were able to identify, but because when I made the question, I didn't realize that. Okay. So we will just remove this one. 8 Newton is not possible. So let's increase its value a bit. What shall I do? 15. 15 is fine. Okay. Let's make 15. Now try. First calculate common acceleration. Tell me how much it is. What is common acceleration? Come on.
0.5, sir.
Yes. Yes. This is 15 minus this friction here, which is 10, by the total mass, which is 10. That's 5/10, 1/2. So common acceleration is 1/2 meter per second square. Now let us check it's possible or not possible. So on which block we are going to check? On which we have not applied force, that is 6 kg block. Come on, check it. Check, students, check whether it's possible, not possible. What is limiting friction between 4 and 6? Limiting friction between 4 and 6 kg. How much it is? Yes,
10
students.
newtons.
Which one? How much it is?
10 newtons. Sir.
Friction between these two.
Sir, no. No.
20 Newtons, sir.
20
No.
Newton.
20.
Yes, it's 20. This is 20 Newton. Now this is 20. This is 10. So net force is 10. So 10 equal to 6A. That means acceleration is 5/3. Yes, it's possible. This limiting force can make this block move with what acceleration maximum? 5/3. And here what we require? Only half. We require only half. That means force limiting. FL is more than required value. How much we required? We wanted it to move just with the half meter per second square. Right? We wanted it to move with half meter per second square. So for half meter, how much FL was required? Okay. How much FL would have been required with half? Just you can check. FL minus 10 equal to 6 into 1 by 2. That means FL required was just 13. And how much is available to us? 20. So definitely both are going to move together. In the previous question, they were moving separately. Here they are moving together. Did you understand? And once you know that they are moving together, our answer is half meter per second square. Is this clear? This step, is this step clear? That is more important. Okay, first thing is you calculated FL value is 20. Don't keep it over here. Okay. So FL value we have calculated, that is 20. Fine. Let's keep it here. Then this is the friction here. This, let's say, is required. Okay. And acceleration, how much we want? 1 by 2. See what's coming. F required minus 10 equal to 6 into 8. That is F required equal to 10 plus 6 into 1 by 2. That is 13. Right? Now we know if FL is more than F required, then both blocks will move together. Then both blocks will move together. So if they are moving together, our answer is half. Is this clear?
Yes, sir.
Okay.
Yes, sir.
Note it. Completed?
Complete.
Yeah, okay. We'll finish the class here. Friction is also over. Okay? Friction is over. Tomorrow's class, we are going to start work. Okay? And get ready for the exam. Possibly on Sunday, we will have exam on laws of motion and friction. Is that okay?
Yes, sir.
All right then. See you tomorrow. Bye-bye.
Thank you, sir.